My name's Steve Mykytyn. I'm the corporate technical trainer here at AprilAire, and I really appreciate everyone taking the time out of your morning to attend our NATE webinar on dehumidifiers. It was below freezing this morning here in Madison, but we are definitely moving out of heating season, and so now it's time to talk about dehumidifiers. I think there's going to be a lot more webinars in my future with the way everything's going. So looking forward to the ability to interact with a lot of you over the next couple of weeks through this type of a format. If you've ever listened in on any of these webinars, you know we get a lot of people listening in, which is great, but unfortunately it also means that I'm not going to have time to answer your questions. But as always, please submit your questions using the GoToWebinar tool, and I will do my best to answer those in a timely manner. Just be patient with me. I'm not ignoring you. It just sometimes takes a few days to get back to you. All right, let's get started. So, since it is a NATE class, we want to talk about some science type stuff with dehumidifiers, and then we'll talk about dehumidifiers in general. But first, I've started using this slide this year. All of our products, the dehumidifier, humidifiers, air cleaners, all those products are manufactured right here in Wisconsin. Great group of people. Some of it's done in Madison, some of it a little bit north of us in a town called Poynette. And so just wanted to include this slide as a way to make sure that you guys know that we appreciate your business, not just the sales department, but manufacturing as well. So we've got a lot to cover. I want to get started, and I do my best to get this done inside of an hour. We'll see if we can do that today. So start out with the basics. Humidity. To get significant amounts of humidity, you need heat, you need water, you need airflow. Pretty straightforward. You're evaporating moisture. Then we've got to figure out in the cooling season what to do with that. So this is showing you how relative humidity is impacted by temperature. The concept is, although the temperature changes, the relative humidity will also change. This is because as you warm air, it can hold more moisture. As you cool air, it holds less moisture. With a dehumidifier, we're using that concept to cool the air to the point that we reach 100% relative humidity. We cool the air so that it can't hold the moisture that's in it anymore. And that's referred to as the dew point temperature, the temperature that you get condensation or dew inside the dehumidifier. We're cooling that incoming air down to the point that the water condenses out, just like the evaporative coil on your air conditioner. Let's talk about why we want to put a dehumidifier into a home. By keeping the relative humidity low, typically below 60% or maybe a little bit drier than that, we can reduce or even eliminate the sort of stinky sneaker smell you get with mildew and mold spores in the space. You've got wood floors, wood cabinetry, musical instruments, even wood-framed windows and doors. If we can control the humidity levels, we can prevent those wood materials from expanding too much. Dehumidifier is removing moisture from the air. It's actually reducing the absolute humidity. When you're thinking about an air conditioner is removing both sensible energy and latent energy. Sensible would be the temperature that you feel. The air conditioner cools the air down, of course. But the air conditioner also condenses water out of the air. That's removing latent energy or latent heat as a way to cause that moisture to condense out. When you add a dehumidifier, the dehumidifier is designed to remove a significant fraction of its total BTUs as latent. So it's doing a good job dehumidifying the air, removing moisture from the air, condensing water out of the air. By reducing that latent load, your air conditioner becomes more efficient. It becomes more effective because it can devote a greater proportion of its 12,000 BTUs per ton to cooling the air down, to removing that sensible heat or that sensible energy. A side effect of this, keeping the relative humidity under control, is that human comfort, what we experience as a comfortable indoor condition, is related not just to temperature, but also humidity. You'll be comfortable at a warmer temperature if we can keep the air drier. The impact to the consumer is, if they're using a whole home dehumidifier to keep the relative humidity lower, they can adjust the cooling set point on their thermostat. If they do that action step, then they will save a significant amount of money on their cooling bill. Even if you have a two-stage air conditioner or a variable speed, true variable speed air conditioner, which do an excellent job dehumidifying when they're running, it still makes sense to install a dehumidifier in that home, because there's going to be lots of times when the home is the temperature that the occupants want, but the relative humidity is still too high. Think about shoulder seasons, spring and fall. Even in the cooling season, in the morning, overnight, cloudy days where there's not a lot of heat gain, so the air conditioner is not running a lot, you're still going to have muggy air coming into the home. That can raise the relative humidity too high. So how does the humidity get into the home? Sure, some humidity comes in from cooking and showering and laundry and watering your plants, but the vast majority of the moisture in the home comes from where the home interfaces with the ground. Basement, crawl space, slab. That moisture moves into the space. And then, because of the stack effect, which is warm air rising through the home, and then of course escaping through soffit vents or ridge vents, that depressurizes the home, and that draws moisture in from the lower half of the house. Cooler, more humid air. Think about a basement or a crawl space. The air being pulled into the home to replace that warm air that just escaped is coming from that basement or crawl space. That's bringing moisture in with it, adding absolute humidity to the home, causing the relative humidity to climb. Here's just a little bit of an animation to show you how this process works. And so you've got a sort of on the left, a basement, on the right, a crawl space. Just very simple illustration to get this idea across. And then you can see the moisture coming through the ground into that space and then migrating up into the occupied part of the house. We're trying to reduce mold and mildew. These things, of course, are a health concern, but they also can cause structural damage. So these pictures show quite a bit of mold and mildew growth. I just want to point out that if you can see a lot of mold coming through your drywall, remember, mold likes to grow in the dark. So it's growing inside that wall cavity, and it's just coming through the wall. You'll see mold colonies on the exterior of the drywall, but it's also growing behind that wall quite aggressively. A dehumidifier is not going to remove the mold, but it's going to keep the ambient relative humidity low enough that you're not encouraging mold growth. So this still has to be opened up and remediated in some way but we can keep the ambient relative humidity down so we're not encouraging that growth. This is a very popular chart in the HVAC world. Works both in raising the humidity in the heating season as well as lowering the humidity in the cooling season. Let's talk about lowering the humidity. So across the bottom, you have the indoor relative humidity in terms of a percentage from 0 to 100%. And then down the left-hand side, you have different indoor air quality concerns or problems. The red triangles represent how much of an issue each of those indoor air quality factors is going to be at various relative humidities. The idea is the red triangle gets skinnier as the concern decreases. And it's pretty easy to see that the triangles get very skinny or disappear entirely when you get into the middle range there, what's labeled the healthy zone, and that's going to be from 30% to 60%. So in the cooling season, we're concerned with lowering the relative humidity into that healthy zone. I want to just take a couple seconds and make sure everybody understands what this chart is saying. Let's take a look at bacteria and viruses, molds and fungi, and dust mites. Let's just focus on those. You can see if we keep the relative humidity below 60%, so maybe 55%, we're going to eliminate bacteria, viruses, molds, and fungi. We're creating a space, the ambient conditions, where those things aren't going to thrive. That's the goal. We're starving them of moisture, so they're not going to thrive. That's at, say, below 60%, so 55%. If you've got people that have bad allergies or asthma, they may be concerned with dust mites. Dust mites are ubiquitous. They eat dust, and most dust in the home is skin cells. So we're making food for the dust mites all the time. A lot of people are allergic to dust mites. If we can keep the relative humidity below 50%, then we can create the conditions where dust mites are not going to thrive. I want to stress that maybe is 48%. That's a good target. That's going to address the mold and mildew, the fungi. That's going to address the dust mites. I strongly encourage you to stick with those numbers, below 60% or just below 50%. Don't sell the dehumidifier on the promise that you're going to be able to maintain 40%. That's going to have to be a very, very, very tight house. And even then, you're going to make the dehumidifier run a lot. The important thing I want you to focus in on is what have we gained by going from less than 50% down to 40%? We've gained nothing. In fact, we might cause some things to be more of an issue. So save yourself some headaches. Save an awkward conversation with tech support. Keep the relative humidity below 60%, so set the dehumidifier to maybe 55%. Keep it below 50%, so it's maybe 45% or so. Those are the numbers you want to shoot for. All right, with that in mind, let's talk about the product. Dehumidifier is an incredibly flexible tool. It's a problem solver for a lot of different problems in the home. And so that's going to result in it being installed in a variety of places. Let's just kind of go through it together. Some of these will apply to you depending geographically where you are and how homes are constructed. Some of these won't apply. So, first and foremost, if you have a house with a basement, a lot of times we want to do whole home dehumidification. One way to accomplish that is to duct the dehumidifier to the HVAC system. So the HVAC system is the basement. Dehumidifier is also in the basement, ducted into and out of the return, thereby dehumidifying the whole home. You may want to focus on dehumidifying a specific area in the basement. Maybe it's a home theater. Rather than have the dehumidifier sitting in that area, you can remote locate the dehumidifier in another area and then add dedicated ductwork and a couple dedicated grills so that you can pull air from that space, dehumidify it, and push that dry air back into the space. That way you don't have to see it, you don't have to hear it. You may just have the dehumidifier freestanding in the basement. This might be just to dehumidify the basement, but in most cases, you're also going to affect an improvement in the relative humidity upstairs. And again, that's because the moisture is entering the home from the basement, and then that moist air is being drawn up into the occupied part of the house. If we dry the basement air out, that moisture load isn't there anymore to migrate into the upstairs. You may locate it to do whole home dehumidification. The HVAC system happens to be in the crawl space, so the dehumidifier is in the crawl space, not to dehumidify the crawl space in this example, just ducted into the HVAC system to dehumidify the whole space. And then, of course, if you're going to seal up the crawl space and put down a vapor barrier to encapsulate it, once you do that, then you can dehumidify it. Once you've reduced the amount of airflow into and out of the space, the air changes per hour, once you've reduced the amount of moisture migrating into the space by putting down an effective vapor barrier, then you can dehumidify it. If you just stick a dehumidifier in a wide open crawl space, every pint you pull out is going to be replaced by moisture coming up from the ground. You're going to have to dehumidify the whole county. HVAC equipment in a closet, duct the dehumidifier into that HVAC system to dehumidify the whole space. Attic installations, that might be where the HVAC system is, so your whole home ducted in. Might be doing a dehumidifier in the attic with dedicated ducts to dehumidify the whole house, but using dedicated grills in a hallway or a large open area. And then finally, in the upper left-hand corner, this is getting very, very popular. When you seal up your attic space, so you spray foam it, you close up all the vents as a way to reduce solar gain, what happens is that stack effect still happens, but now you've sealed up that crawl space, so there's nowhere for that moisture to go. So it accumulates in the attic. And if you don't address that, you can have a very significant mold problem in that attic. So a lot of companies are putting dehumidifiers in the attic just to dehumidify the attic to address that concern. All right, let's take a look at the dehumidifier. If you think of it as a split air conditioner in which both the indoor part and the outdoor part, the evaporative coil and the blower, and the condenser unit are all put together in one cabinet, that's a dehumidifier. So let's walk our way through it. The user interface is going to sample once an hour. It's going to run the blower for 3 minutes. So we're going to pull in quite a bit of air, lots of cubic feet of air. So we're getting a good representative sample. Assuming that the space is too humid, blower is going to keep running. We're going to turn on the compressor. First thing that the air is going to hit is going to be the evaporative coil. Evaporative coils are now all made out of aluminum. That makes them very corrosion resistant. We still aren't going to use these in indoor swimming pool applications. They're not designed for that. But they still are going to be quite good at handling ambient moisture. So that's the coil that gets cold, cools the air down below dew point, water condenses and drains away out the drain fitting. Next thing the air hits is going to be the condensing coil. So that's going to warm the air up. And then the air is going to continue across the compressor, which is located behind this electrical box, and then out the unit. The air comes out a little bit warmer, but a whole lot drier. Another way to say that is we have removed a lot of latent heat or latent energy. We have added a little bit of sensible heat or sensible energy. The take-home message there is we do not want to adjust our manual J calculations. The last thing you'd want to do would be to oversize an air conditioner because you're putting in a dehumidifier. That is going to create a cascade effect where that dehumidifier is going to have to run a lot because that air conditioner is going to short cycle. It's not going to give us any dehumidification, and so that dehumidifier is going to be forced to run a lot. So just use your standard manual J's for residential and add in that dehumidifier based on our very simple sizing chart, and you'll get good results. The air conditioner and the dehumidifier will work together. We have a nice unboxing video on our website, AprilAirePartners.com. Just want to give you a quick synopsis here. So, of course, it comes with a dehumidifier. It includes a permanent, washable, reusable filter. We use Torx heads. We include a Torx bit to make it easy if you ever have to open the unit up or move the collars or move the user interface. We include a threaded drain connection. We'll talk about that a little bit more later. And then 2 collars. The inlet collar does not have a backflow damper. The outlet collar does. When you get a dehumidifier from AprilAire, we want you to cut the zip tie and remove the shipping bracket. Those are in place to keep the compressor from moving more than it should if it's a little bit aggressive when it gets shipped. If we end up getting it rattled a little bit, or heaven forbid, turned on its side or upside down. We want to remove those things because that shipping bracket and zip tie are going to, if they're not removed, transmit the vibration of the compressor into the dehumidifier cabinet. It's going to make it louder. So just cut that zip tie, remove that shipping bracket, and the compressor can vibrate like it should. Depending on where these dehumidifiers are going to, where they've been stored, sometimes the insulation can get a little warm, gets a little tacky, and it can get the zip tie stuck to it. So don't just cut the zip tie and then yank out the zip tie like you're starting a lawnmower. Sometimes you can pull off a big chunk of insulation, and that's going to be challenging to get that insulation back on. So just kind of cut it. And then if you just kind of wiggle it loose a little bit, if it is happen to be stuck, then you can pull it free. Takes an additional 15 seconds, and you'll save yourself some headaches. If you're going to be ducting it, we include collars. Like I said, there's a backdraft damper built into the outlet collar. The collars themselves have some molded tabs on it to make it easier to attach flex duct. Makes it easier to trap the flex duct and get that zip tie tightened down on it, cinched down on it. I want to point out a really nice feature. The discharge side, the outlet, can either be coming out the end, so it's like straight through the dehumidifier, or it can come out the top. That's field adjustable. You can see there's a collar and a blank off plate. Same adjustability is available with the user interface. The user interface can be on the top or on the end. If you're putting this into a crawl space, it's only maybe 3 feet high, probably want that control to be on the end. If you're putting it in a basement where you're looking down at it from the top, it'd be nice to have that control on the top so it's easier to see. That's the idea. The standard units come with adjustable feet, and that's because most surfaces where these get installed are not going to be level. If you're putting this in a crawl space, it's probably not level. If you're putting this in a basement with a floor drain, the floor is going to be sloped towards that drain. We want to use the adjustable feet to level the unit, make it level and plumb, front to back, side to side. The drain pan has a molded slope in it, so if you make the unit level, the drain pan will allow the water to drain properly. Sometimes we'll get units that are leaking, and the first question we're going to ask you, so don't get offended, don't get mad. The first question we're going to ask is the unit level front to back and side to side? Because that's usually the cause. You don't need to help it drain, is what I'm saying. We've made some changes to the drain fitting. Makes it much easier to install. We've gone to a threaded fitting, and we include a threaded hose barb fitting. We've also adjusted the size of that hose barb fitting so it uses your standard flexible tubing. So if you're going to use flexible tubing, it's 3/4 inch ID. Just thread in that fitting. Obviously don't glue it. You can wrap it with Teflon tape if you wish to, and then that hose barb just would accommodate that 3/4 inch ID tubing. If you prefer to use PVC, don't use the threaded hose barb. Just go with, from your plumbing supply store, a threaded to slip fitting, and then you can use your 3/4 inch PVC. There's a lot of features in the dehumidifier. I'm not going to go into them all. The vast majority of installs, you're going to leave everything set to the defaults. If it's freestanding, you're just going to set the relative humidity and let it rip. If you're ducting it into the HVAC system, you're also going to wire it to the HVAC system so it can make the HVAC blower run. But again, you wouldn't need to adjust any of the other settings. Just pick your RH set point and let it sample and run. And it'll sample. If it's too muggy, it'll run its compressor and it'll make the HVAC blower run as well, so you can dehumidify the whole home. The vast majority of installations, you don't have to get into the installer setup. The features are there, the options are there if you need to take advantage of them, but in most cases you don't need to. If you have questions or you're interested in the features, give our great tech support group a call, and they'll be happy to talk about your application, your installation options, and they'll talk about what features might benefit you. I'll just touch on a couple quickly. You could have this unit controlled by its onboard control or by an external control. You can also have it remotely monitored if it was in an attic or crawl space. It can even bring fresh air in if you're doing a ventilation application. There's a variety of features. I just don't want you to feel overwhelmed. Most of the installations, it's very, very quick, very, very easy, nothing to adjust. So let's go into a little bit more detail on the controlling side. Again, high-level overview. Of course, it comes with an onboard control. Onboard control, you're going to set the relative humidity. The unit's going to sample for 3 minutes every hour. If it sees the air is too humid, it's going to run as long as it needs to lower the relative humidity. Could be half an hour, could be a month, whatever it needs to do. You may not want to use the onboard control. You can be controlled externally. You would enable external control, and then any device that can provide a dry contact can tell the dehumidifier when to run and tell the dehumidifier when to stop. So you could use one of our humidistats or a competitor's dehumidistat. You could use an IAQ thermostat or a Wi-Fi IAQ thermostat, anything that provides a dry contact closure, even a building automation system. So it's very, very flexible. If you're putting this in an attic or a crawl space, you still want to measure the relative humidity in that space, because that's what you're trying to dry out, but you don't want to have the consumer go into that crawl space or attic to see what the dehumidifier is doing. We offer a remote control. You'd use our Model 76 and then enable remote. You may be putting these in a time of year where the unit's not going to need to dehumidify. So rather than try and trick it with a wet paper towel or something like that, there's an installer test mode where you can put it through its paces. Very simply, it'll at least sample and run the compressor, but if you've got more options selected, it'll also put it through all of those paces as well. The basic operation is going to go through that 3-minute sample, turn on the compressor so you can make sure everything's working like it should. The dehumidifiers come with an on-off rocker switch. It's located on the same end of the dehumidifier as where the power cord enters the unit. It's located right above that power cord. If you plug in the unit and the screen doesn't power up, even though you're pushing the soft key labeled on-off on the user interface, it's not DOA. Just make sure you've got that on-off rocker switch hit to on. The on-off rocker switch is there as a positive cutout so you can do service works if you open the unit up. That's what it's for. Normally you'd leave that on and you would just use the soft key to turn it on and off. But you'd be surprised how many calls we get on units that are supposedly DOA, and it's just a conversation about locate that on-off rocker switch and hit it on. Other than that, it's simply first button push lights up the backlight on the LCD screen, and then you use the up and down arrows to adjust the relative humidity setting. That's it. I'm not going to go through all these settings. I just want to show you that the screen itself will display using real words, full words, complete words, exactly what it's doing. So if you see it say air sampling, then that means just the dehumidifier blower is running. That's during that 3-minute period. So that's why the compressor is not running. It's air sampling. But if it says dehumidifying, then that would be when the compressor and the dehumidifier blower would be running at the same time. If you enable external or remote, you're doing fresh air ventilation or zoning or what have you, then those other words would be displayed on the screen to tell you exactly what's going on. Makes your life very, very easy. You don't have flashing lights or codes to try and decipher. Lots of control options. Onboard control, you see pictured there. One of our very nice 2-piece Wi-Fi IAQ thermostats that happens to be the 8920W. And then that's our 76 control located below it. All right, let's talk about the models a little bit. There's 3 basic capacities: 70 pints per day, 95 pints per day, and 130 pints per day. All dehumidifiers are tested and rated at the same conditions. It's 80 degrees Fahrenheit and 60% relative humidity. Then you can see we've broken those down into models based on their capacity: 1830, 1850, and 1870. 1850 is probably going to be your sweet spot unless you're doing crawl spaces, in which case it might be the 1830 or one of the variations thereof. When you get to the 1850, there's a couple options. 1850W is a hardwired unit. Some municipalities require that the dehumidifier be hardwired if it's located in an unconditioned part of the house. That's code. Usually the logic behind that is you don't want rodents gnawing on the power cords. 1852 is, instead of the adjustable feet, it has casters on it. If you've got a tight location, it can be easier to roll it into position than to try and lug it into position. And then our large capacity unit, 130 pints per day, is the 1870, has that same hardwired or caster version availability. We have spec sheets online, AprilAirePartners.com. I'm not going to go through all the specs. I just want to point out a couple things. We talked about the capacity. Look right below that, the energy factor. 2 liters per kilowatt hour. What does that mean? It means for every kilowatt of electricity we expend, we're going to remove a 2-liter bottle of water. Again, that's at 80 degrees Fahrenheit, 60% relative humidity. But I also want to point out the amount of air that this unit's going to move. That's a key component to the dehumidifier actually being able to achieve that rated capacity. If you've got a portable, it's only moving a little bit of air, maybe 40 CFM. So it's not churning the air in the space. And so it's effectively dehumidifying a bubble of air around it. It hits set point, it shuts off. Then you have to wait for that humidity to migrate back in for it to then run. So you get lots of downtime. By moving as much air as we're moving, you're constantly pushing the dry air away and pulling more humid air in so it can keep dehumidifying the space. I also want to point out the amp draw is quite low, only 6.3 amps, and the unit's relatively quiet, especially when it's ducted. 47 decibels is quite quiet. (1852), same specs. You can just see the casters pictured there. Oops, sorry about that. Here we go. 1850. We bumped up to 95 pints per day, but it's also more efficient. we're at 2.2 liters per kilowatt hour. More capacity, more miserly when it comes to using electricity. Moves a lot more air, draws 8 amps. Still pretty low and still pretty quiet. 1870, 130 pints per day, almost 3 liters per kilowatt hour, 2.9. So very energy efficient. It only draws a third of an amp more than the 1850. So not much more amp draw, whole lot more water, and it's more energy efficient to boot. Again, that's a very large capacity dehumidifier. That would be for a very large space or a very large home. Typically, the 1850 is going to be the unit you're looking at. And our tech support group would be more than happy to help you size a unit, talk about options. Does it make sense to have 2 dehumidifiers because you have 2 HVAC systems, or the house is sprawling, or what have you? 1820, I'm just including this because sometimes it comes up in conversations. This is a more compact unit than the 1830, same capacity, just a little bit more compact, so it's a little bit easier to squeeze that into a crawl space. Just want to show you, we've got specs. If you're looking for specs, we've got specs. To make the installation as easy as possible, thinking about all the different ways it can be installed, we've got quite a few accessories. We've got hanging kits, so you can hang it, save some floor space. We've got a condensate pump. It's a you can use any condensate pump you wish, but the condensate pump we offer is a low profile condensate pump, so it fits nicely up against the dehumidifier. We offer a living space kit, which is going to be the 2 grills you see and flex duct and some zip ties, so that you can have it dedicated into and out of a room for a remote installation. And then one of the more complicated installations is where you're actually dehumidifying 2 separate areas, typically the whole home, and then focusing on one specific area. You can use motorized dampers to do that. Again, uncommon, it's a problem solver. Don't think you're going to be installing it that way all the time. A quick, simple way to make sure the unit's working like it should is simply to note that when it's running, the air comes out a little bit warmer. As I said previously, a little bit warmer, but a whole lot drier. There's a huge difference in how warm the air can be. It depends on the relative humidity and the temperature of the air. Approximately 15 degrees. Could be a little bit less, could be a little bit more. That gives you an idea. Here's the sizing chart. Very, very simple. Very, very easy. No psychrometrics involved. We've done that math for you. First thing, got a map of the continental United States. Figure out what area in, A, B, or C, and they're broken up based on how humid the outside air is. So that's going to determine how much moisture load you're adding to the home. We're in Madison, Wisconsin, so we're region A. That means all I have to worry about on the chart is the row labeled region A. The top of the chart, you see models, and then below that do you have 1 air change per hour? That's what ACH is. Or do you have half an air change per hour? A typical tight house built in the last, say, maybe 10 years is going to be half an air change per hour. Even an older home that's had some significant renovations done to it, better windows, better doors, some weather stripping, some sealing, that could have a half air change. An older home that has not had a lot of renovations done, that might be 1 air change per hour, just to give you a ballpark idea. The key here is you can't oversize a dehumidifier. So if you're not sure, go with the 1 air change per hour. And of course, call our tech support group. They'll be happy to help you figure that out. So let's assume region A, half an air change per hour, relatively tight house. Then you look at below that, you can see it lists square feet. Square feet. Whenever you see a chart like this, our industry always assumes 8-foot ceilings. If you've got a 5,000 square foot house, you probably don't have 8-foot ceilings, so just calculate out the cubic feet. then you know the volume. Makes it easy to figure out which unit you need, or if you need multiple units, how many. So multiply it by 8 to get the cubic feet. And so you could see region A, half an air change per hour. The 1830 could do up to 3,800 square feet with 8-foot ceilings. The 1850 up to 5,200 square feet with 8-foot ceilings. And then the 1870, half an air change per hour up to 7,200 square feet with 8-foot ceilings. Typically at that point, you'd probably want to go with 2 smaller units just because of the physical size of that space. Any questions about sizing, please don't hesitate to give us a call. A big mistake that contractors make is not thinking about the ceiling height. It's not uncommon to have a home with 10-foot, 12-foot, or maybe some cathedral ceilings. That's volume. That's space that has air in it, air that has moisture in it. So you have to consider that. Part of the user interface is covered up by that little plastic door. When you take that door off, you can see inside of that are your screw head terminals. If you have to do any wiring for whatever options you've selected, you just pop that cover off and do your wiring there. You're not opening the unit up to get to the internals to do the wiring. Just very simple, very straightforward. If you do end up doing some ducting, we strongly recommend going return to return. Pull the air from the return, dry that air out, and push that dry air back into the HVAC return. In this application, you're going to pull the air out first and then reintroduce it downstream, at least 6 feet downstream. That's going to prevent short cycling between the inlet and outlet of the dehumidifier. You're also going to wire the dehumidifier to the HVAC system so the dehumidifier can energize the blower when it's dehumidifying to help pull more humid air to it and push that dry air away. Figure 11 shows this ducting return to return on an upflow, and figure 13 shows it on a horizontal. We don't recommend return to supply because of the static pressure limitations. If you know when your HVAC system is running on high speed that the static pressure is less than those amounts shown there, you're more than welcome to duct it return to supply. I just want to point out that more often than not, the static pressure ends up being higher than you might assume, and so the unit's not moving air like it should. Here's some great crawl space pictures. You can see there the unit's up on some stands. You can see a condensate pump to pump the condensate away, and in this case it's open on the inlet and ducted to the outlet. Dehumidifying that entire crawl space. There's lots of options. I'm not going to go through each and every one. I just want to kind of give you an idea of how flexible it is. So here's a close-up view of that remotely located with dedicated inlet and outlet ducts and grills. So we're dehumidifying the space behind that wall. And I would say, it says 6 to 10 feet. I would say keep it 10 feet apart. Why would you risk short cycling it? You want to dehumidify that space. So 10 feet. Another option, you could have it open to the basement, let's say, or some other space, and then duct it into the return. Closet installation. If the HVAC system is up on stilts with the air cleaner located underneath, you could fit the dehumidifier underneath it, and they would simply share the louvered return opening on the door. And then figure 16 shows if you couldn't do that, you could squeeze the dehumidifier into the closet and then duct it to the supply. This is the zoning application, so we're dehumidifying a local area as well as the whole house. Not going to do this installation very often, but it's there as an option. It's there as a problem solver. I mentioned before, it can also do fresh air ventilation. You can do it based on minutes. That would give you your ASHRAE, fresh air ventilation requirements, or you can choose to wire in an optional outside temperature sensor, and then you could pick between some outdoor temperature lockouts. This wouldn't give you AprilAire, but it would give you the ability to control when the fresh air is happening. This is a great way to confirm that the unit is truly working exactly as it should. I mentioned earlier how you can just check to see if there's warm air coming out of the unit. That's pretty straightforward. But by actually using the unit's built-in smarts to measure the refrigerant temperature, we've got a sensor on the suction line, so that's going to get cold when it's running. The only way to make that air coming out get cold, the only way to make the refrigerant get cold is by having the unit working well. That's going to be your best way to do it. It's very simple. Button combination. It's going to read to you the inlet air temperature, the inlet air relative humidity, and that suction line temperature. So you do that right when you install the unit. So the suction line temperature would start off at the ambient temperature. Then you let it run for maybe 15 minutes. Do that same button combination to make sure that that suction line temperature has dropped. You can jot those numbers down, give tech support a call. They'll be happy to give you some additional information, or of course, we're happy to walk you through that process. Our dehumidifiers are monitoring a lot of things. There's got a lot of smarts built into it. If you think there's a problem with the dehumidifier, I would expect that you would see an error code. Makes it very easy. What are you getting? E1, E2, E3, etc. It also says service required, so it's a very clear indication that there's an issue. The screen looks much different. It's not saying sampling or dehumidifying. It's actually saying service required. It's a great way to, if you get a call from a consumer saying that the unit's not working properly, if you wish to, you could have them tell you what the error code is, and makes it very easy for you to diagnose what the problem might be. And of course, tech support is available to you. To make your life even easier, on the back of that cover that was covering the screw head terminals, you can see there's a little brief description of the error codes. There's also our toll-free number for tech support, as well as the hours of operation, 7 a.m. to 5 p.m. Central Time. Call up tech support when you're in front of the unit. Tell us what the error code is. We should be able to help you out pretty quickly. For the homeowner, when the cover's in place, tells them how to turn the unit on or off with the soft key, how to adjust the relative humidity setting, and if they see the change filter indicator, they can watch that filter and then they can reset that reminder. Very, very simple, very, very straightforward. I'm not going to go through the diagnostic codes here. We wouldn't be able to give enough detail to be really helpful, but if you ever do see a dehumidifier with an error code, call us when you're on site. We can typically either explain what's happening and get the unit running in one call, or we can troubleshoot it, diagnose a bad component. If there happens to be one, oftentimes there's not. I would say usually there's not. And then tell you what part number to pick up from your distributor if it needs to have something replaced. Talked about the clean filter. It's just a timer, so it's going to trigger typically twice a year. I've mentioned that MERV8 filter a couple times. There is an access door on either side, so again, keeping it as flexible as possible. Typically, you're going to use the onboard control, but if you choose external, like I said earlier, it's any device that can measure relative humidity and provide a dry contact closure when you want the dehumidifier to dehumidify. Hour 76 can be used in external mode or remote mode. Remote mode, it does communication. It's the only thing that can do remote mode. Here's the wiring. Again, depends on what product you're wiring in for external control. 2 for power, 2 for control. Simple as that. Screen's going to give you very similar information to what you'd have using the user interface. So it's going to show you the relative humidity it's measuring. It's going to flash the word on when it's actually dehumidifying. You can adjust the dryness level, and you can turn the unit off so it doesn't run. With remote, again, that's only the 76, and this is going to be used in a crawl space or an attic installation. A nice thing to think about is using one of our Wi-Fi IAQ thermostats to control the dehumidifier. This conceptually makes the dehumidifier a Wi-Fi dehumidifier. So you don't ever have to go to where the unit is to see what the relative humidity is. You can simply look at the app on your smart device. Want to cover why would you buy an AprilAire dehumidifier instead of a portable? Start with the key of any AprilAire product, the quality controls, the quality assurance. We know when we ship this unit, it does not have a refrigerant leak. We pressurize it with nitrogen. We pressurize it with helium. The nitrogen catches larger leaks. The helium finds very, very small leaks. The helium molecule is far smaller than the 410A refrigerant. So if you can't sniff out any helium, you know you're not going to have a problem with refrigerant leaks right out of the box. We also pressurize it. And then, of course, to prepare it for adding the refrigerant, we have to draw down a vacuum. We draw down the vacuum to purge out the helium and the nitrogen. We draw down the vacuum to flash evaporate any moisture that might be in there. But we make it hold that vacuum for 60 seconds so we know that there's no leaks opening up under pressure. There's no leaks opening up under vacuum. All metal construction, very quiet. Depending on the application, you can have a dew point control or a relative humidity control. In addition to having an adjustable set point, we have, as I've mentioned before, some pretty clever, smart things. What's going to cause a portable dehumidifier to fail? You go to the big box store, you buy a portable dehumidifier, 3 to 5 years later, it's not really dehumidifying anymore. That's because, let's say you set that unit to 50% relative humidity. It's going to come on at 51, it's going to shut off at 50. Remember, it's not moving much air, so it's going to not take very long to dry that bubble of air out. So the compressor turns on, compressor turns off, compressor turns on, compressor turns off. We all know compressors like to run, compressors do not like to start. That is a significant shortening of life on that compressor. What we do is, let's say you set it to 50%. We're going to turn on at 51, but we're going to depress that relative humidity. We're going to dry it out 3 percentage points below your desired set point. So come on at 51, shut off at 47 in my example. That gives you much longer run times followed by much longer off times. And that's good for the compressor, and it means that most of that time the coil is cold and you're very efficiently removing the moisture. We run the blower for 3 minutes every hour to get a good sample. 5-year bumper to bumper sealed system. So in that 5 years, any parts that fail, we would replace. If it's a sealed system failure, if our tech support group determines it's the compressor or refrigeration system within that 5-year period, tech support, when they determine that, will authorize the whole unit to be replaced. And as I mentioned before, we've gone to all aluminum coils. Here's a little bit more detail on that. Again, not labor, parts for 5 years, and if it's anything with the refrigeration system, what we call sealed system failure, tech support will figure that out for you, and then we would authorize a unit to be pulled from your distributor's inventory. Thank you very, very much for your time. Like I said, I try and keep these under an hour. Looks like we've done that. I want to leave this splash screen up so you can
send me any questions you might have using the GoToWebinar tool, but I also want to make sure you know our 800 number, 800-334-6011. This is customer service or tech support. They can help with model selection, application, installation, and of course, troubleshooting. I also want to make sure everybody that's listening in is familiar with our contractor-only website, AprilAirePartners.com. AprilAirePartners.com. This is where you're going to find spec sheets, installation manuals, marketing information, training webinars, unboxing videos. This is where we store these NATE recorded webinars. Lots and lots of information there for the contractor. Thank you very, very much for your time. I really appreciate you taking the time out of your morning, and enjoy the rest of your day.